Alright, old Gatekeeper here. We got ourselves here a very, very nice amplifier. See if I can get the front of it without having to turn it around. Now, this amplifier right here is very cool, very unique. It is geared towards more of the ham community. It is a full HF amplifier equipped with 4 Toshiba 2879s. And the real cool thing, neat thing about this amplifier, by the way, we got the old infamous Jack in here with us, chilling, hanging out, chilling like a villain, staring at the ceiling, sipping on penicillin. These were sold as kits. I'm not sure if you could buy them already assembled or not, but they were sold as kits, and they have documentation that comes with the kits that it's just absolutely informative. Honestly, the information that comes with these kits are one of the most informative pieces of documentation that I think I've ever read. You know, coming from just somebody that's designed his own amplifiers, you know, and selling them. What I like about him is he doesn't just show you what you need to do to put the kit together, but he explains why each and everything is done. I actually have already read the documentation. It took me about a week or two just reading a little here and there. About the only thing that I didn't see him explain in there is, well, maybe he did, but I didn't see him explaining why he went with this value for the input balancing resistor. And he really didn't explain about the output either. You would think this right here would need to be 100 ohm, but it's a 200. But everything in here is done the way it is for a reason, because this is geared towards HF wideband amplification for wideband use. That's why you're going to see so much. That's why you're going to see that the feedback circuits on this bad boy looks a little different than what you'd normally see. Putting all these resistors right here in a parallel series combination is because he's really putting a lot of he's really neutralizing each section with feedback to help equalize the amplifier through a wide bandwidth of usage. But basically, this amplifier was sent to me to have some basic things done to it. The switch right here is broke off, as you can see. Now, this isn't the version that has, you can see right here in the front, I guess there was a version that had input filtering. I'm gonna be quite honest with you, I don't know where the heck the low pass filters would have went. Just looking in here, there's no room in this box to put filtering for 2 to 30 megahertz or 160 to 10. But that may be a switch that corresponds with an output filter network somehow. But so there's a couple things he wants me to do to this. We got some. This has been cut before and re-spliced together. It's been burnt. I'm going to replace this right here with a silicone wire, super warm silicone wire that cannot be burnt with a regular iron. And there's a couple other things we're going to do in here. I'm going to clean the amp up, clean all the flux. I mean, this is a beautiful piece of art to me as a builder, because I love all amplifiers. I'm not just in love with narrow banded amplifiers. You can almost say I'm probably more in love with wideband amplifiers than narrow, to be honest with you. But it's kind of unique the way the bias circuit is done in this section. The regulated bias circuit that I've already designed myself is very familiar with this circuit, utilizing with a relay right here. I'm also going to draw some schematics just for future reference. But another thing is, as you can see, if you look at the way that the DC is distributed. We got two bolts right here on the back. We got a bolt for the positive, bolt for the negative. Okay, so the bolt for the negative is really nice. It literally grounds the back of this plate, and it goes straight through the heatsink, through about, let me just get down here and show you. Technically, come on now, zoom. This thing would zoom. There we go. 1, 2, 3. What is that? 3 or 4 fins deep. So that's grounding directly through the heat sink. And just the way that everything else is designed for the ground, you'll notice there is no ground wires going to anything for the actual amplifier itself. That's because everything is relying on heatsink ground. The heatsink is the primary ground, and then everything is grounded to the heatsink. That's the genius of this design. If you'll notice here, all right, brass is about the best thing you can use other than copper for conductivity. And of course you can get into gold, but I'm talking about readily cheap used. It's not going to break your pockets. If you'll notice right here, we got a brass washer and bolt. Right here, brass washer and bolt. All right, and this is grounding the ground plane of the board directly to the heat sink. All right, and if you look right here, the emitters, look how close they are to each brass. All right, now if you look in the middle, you're probably wondering, why are these transistors so close together? Have you ever seen transistors this close together before? If you take a look, he's got an eyelet right there. Let's see if I can see a little better with this one. I don't got my light on out here right now. I just kind of, let me just do this and zoom. See that eyelet? That eyelet's going straight into another brass bolt directly to the heatsink. I'm going to tell you, there's no better way to do a ground of transistors than this. But why are these so close together? See, a lot of people don't even think about this. We think about DC ground, DC ground, DC ground. But a lot of times we don't think about RF ground. See, RF ground flows through these emitters from transistor to transistor. So the closer they are together, that causes less resistance. You remember, current takes the path of least resistance. So the closer they are, that's going to help with a couple of things, probably IMD figures, the closer the transistor, so the emitter doesn't have to travel a certain distance through transistor to transistor. Because you got to remember, we don't look at it because we look at it conventionally, but electrons flow from the ground to the positive, counterclockwise, unconventionally. So that's why they went with this type of design. You'll see this written in a lot of old Motorola publications as well. And the way they've got this utilized is what this is right here. These are 2 ammeters. They're I think they're 50 amp. Here, I'm just going to go ahead and do this right here. Yeah, mod means module. Module 1, module 2. When I first seen it, I'm like, what? Modulation? And then this right here is your DC bolt. Quit crying, son. I can't pay attention to you 24 hours. Come on now. You got anything you want to say to the world out there? Hey, you got anything you want to say to the world? Drop the hammer. Oh, you ready to go to sleep? Yeah, he's used to that sleep. We usually take it a nap right about now. I'll be done just a second, bud. So that's what these are some neat ammeter, current meters, that actually have built-in internal shunts. Really cool. Really cool. They're 50 amps a piece. And basically they've got that done because they basically want you to follow to keep the current at around 50 amps for this amplifier. I'm going to reread everything just to make sure, but basically that's kind of the biggest safety feature of this amplifier. If you can keep this amplifier from pulling 50 amps and less, so if you're beginning to pull more than 50 amps, back down, get off the amplifier quick as you can. That's why. So you basically look at each amplifier individually. And if you see that one module is pulling a lot more amperage than the other, you know you've got an issue going on, stuff like that. So you're able to see it like that. So that is, I do love the way they have the ground going in the system. If I ever designed a system like this, I'd probably run a ground system just like this, to where the whole heat sink is the primary source, is the ground plane, and then everything grounds to it. I really like that. Now, one thing I'll have to admit that I don't like is I don't like wires flowing over things, but it is what it is. The only other way you could have done this differently is to have routed this wire this direction and then tried to feed it like this, but it's like we've got a dog in the front yard out there barking for some reason. I don't know what that's about. Don't even think about it. Don't even think about it, son. He can still get out of here if he wanted to. Don't even think about it. So that's going to be it for now. A couple of things I did notice. I have no idea why this is done this way. We've got wires coming from the main switch up here up front that goes to this relay that are going out of the box and being mounted on the outside. What need is, why did someone feel they had to drill and do this? Why didn't they just, well, never mind, I see why they did. They did that because it was easier just to do that and take this bolt off instead of taking the whole bolt off and putting it over here. So this is kind of what you're kind of having to deal with, since we don't see, there's only one fan on here. That's why I've got this keeping it up like this. I think there actually is supposed to be two fans, but there's not a hot bus on here. Well, as we are used to, there's not a hot bus. This is the hot bus, this ground bolt. So I was actually thinking about maybe utilizing something. I'm thinking, I don't, there's really no reason, I don't think, to need to mount a bus right here just to connect the smaller wire. Because the problem, you got a bolt that's this huge, you know. This is for bigger wires. Yeah, of course you can take smaller wires, but it's kind of hard to take a real small wire like this, and I mean, you see, you're taking a small wire and soldering it to a big connector that's made for bigger wire. Honestly, if you ask me, the easier way to do that would be to just go ahead and take a piece of phenolic board, copper clad board, and not double side sticky taping it. There's nothing wrong with double side sticky taping something on a wall like this if it's not going to be a lot of pressure on it, or you really use some real good double side sticky tape. You buff it, clean the heck out of it so there's no oils or nothing on it, then yeah. But a better way I would rather do is mount the board with screws, at least 2 screws to hold it down, then run you over to the bus, and everything can connect to that. But we'll see. But I will be having to take this bolt out because we're going to be replacing these wires. And another thing I see too is this. Now this is just a manual key. It's just a transmit relay, so you can manually key the box. And I'm going to be doing away with this, just going over everything. I'm going to neatly run it. And there's a couple other things I don't agree with the box too. We have Teflon in this box, Teflon wire, but we have places where there's wire being ran in places near the heat sink that isn't Teflon. That is the huge no-no in my book. If you have a regular silicone, not silicone, but regular wire that isn't silicone or Teflon coated, sitting on a heat sink, and that heat sink gets good and hot, I mean, that wire's going to slowly melt, and over time you're going to get a break in it, and then you got yourself a short. So, in like one of these places I see that just kind of blew my mind. It doesn't appear that the wire, maybe that is Teflon. No, I don't think it is either. You can usually feel Teflon wire. And it appears that the wire that's on the actual the bias circuit is not even Teflon, and it's going up under the board, and it bothers me. Bothers me. Bothers me. I am thinking about replacing that too. I hate it, but it is what it is. Beautiful lamp. Really cool lamp. I'd love to own one of these one day. Love to. All right. Let's dig in and get this thing fixed up for my buddy. He's been waiting a while, and he's been patiently, well, he's been patiently waiting, as patient as he can. Let's just put it that way. I think he knows what I'm talking about. He said he ain't a patient man, but he's doing his best. We'll be back. All right, we got the bolts removed. All brass hardware, really nice. And you can see it is a bit corroded, so we're going to polish these up, get them back shiny so they have the best conductivity. And I'm just going to go ahead and be honest with you, it took absolutely no torque at all to remove these. I didn't even need these. I could have removed these with my fingers, so they were not even torqued on. Wow, that's scary. I also do not see any lock washers. It is a very good idea to use lock washers when you're dealing with electrical connections to make sure that that bolt does not loosen up. So I don't think I have any brass lock washers, but I do have. I do want to start buying some more brass hardware, but I do have some stuff. I can use a stainless steel lock washer, one each, and I've got some stuff I can put on it so that both the metals do not corrode with each other. I've got some perfect stuff I can put on that. I forgot what it's called, but so anyway, we've got the bolts removed. This is what was on there. And I'm going to go ahead and let y'all know right now, this particular quick connector is really nice. If you're dealing with something that pulls less than 50 amps, And of course, I would not want to trust this particular connector with this. These are actually great to use with radios, more higher end radios, but not with an amplifier that pulls a decent amount of amperage. So these are good for lower amperage sources. So we're going to put some good thick 8 gauge on here with some Anderson connectors. So I just wanted to document that. So we'll go ahead and remove all this, and going to remove this. I'm going to replace the switch.
The speed of light has been the same all through history. All we've ever measured is here on Earth in our atmosphere.
All right, brother.
So we don't know that the speed of light is a constant.
Got these all polished up for you.
Try and determine the distance
here's
by the amount
two.
of redshift.
Okay. Nobody knows for sure what's causing the red shift. They think it might be the Doppler effect. If the planet or the stars
What you
moving
call
away,
it? My mind ain't working too well. I'm listening to
you're
this
sitting at a train track and you hear
audio
a train
over here, but
the pitch in the train whistle changes as it passes you.
lock
That's for sure.
nuts.
That's called
Lock
the Doppler effect
washers.
of sound. The theory is that maybe the same
Took
thing
me about
affects
an hour
light.
or so,
That
man,
light
but
is
I got them
affected by a
polished
Doppler
up.
effect.
You
It
got to
could be.
do that with
Okay, not
brass,
arguing.
man. You can't just
But
put brass.
if the stars
It's a
moving
better
toward us, you would
conductor.
get a blue shift. And certainly,
needs to be
some
polished
of the
for
stars
every
do
so
exhibit
often.
a blue shift.
All right.
Scientists
Let's
look
get
out
these
there.
power wires.
Astronomers look out
Some
there
of
and
this
see
nice
some of the
super
stars are
worm,
giving a
man.
blue
God,
shift.
I love this wire.
And some of the stars give a red shift.
All right. We got this bad boy cleaned out for you. Cleaned all the flux out. Did a real good job cleaning this up, man. I always like to take amplifiers like this, their own etched boards, clean them out so you can make sure that there's nothing being shorted. It allows you to see all the traces real well. As you can see, I really took the time and really did the number on this and cleaned it out real good. I'm telling you, man, I really like the way this is built, man, using brass hardware. I can't honestly remember, the last video I made was a little while ago, but you know, I cleaned all your brass bolts. We polished them up with Brasso, and like I said before, both of these bolts wasn't even tightened down. These bad boys are tight now, buddy. They're tight as hard as I could possibly get them. I added you new wire on here. Only thing I haven't done is put your Anderson connectors on there yet. This right here is super worm wire right here. You ain't got to worry about no heat melting this at all. And each of these wires are the same exact length. They're the same exact length. The way I'm dealing with that extra length too is with this ferrite bead. I've just got it tie strapped right here just so it's not moving around during shipment or anything like that. And you know, we replaced this number right here, which is the key or amp, the wire that gives the relay a ground. We replaced that with this shielded cable right here. And as you can see, instead of taking this and running it over the circuit the way it was, now it's ran through the back. A lot cleaner, a lot cleaner. All of this right here has been replaced with Teflon wire. And instead of this going over like it was going right here over to here. We've got that ran in the back, tucked away. We even removed this right here, the wire that was on your voltmeter, and we replaced that with Teflon wire as well. The only thing I did notice, man, is the switch is backwards. So I've got to flip it off to be off, on, and that's off. So I'm gonna have to unbolt this and turn it around. And I was sitting there, I'm so used to mounting switches a certain way, and I forgot that it's upside down, so it needs to be flipped. I'm sitting here looking at that, and to flip that, I am going to have to unsolder all those connections and resolder them. No big deal. No big deal. Alright, so we went to fire it up and everything. First we're going to test the bias current. Another thing I went ahead and did is just made this right here, just so I could key the amp. Alright, since I'm holding the camera now, I'm going to just clip this onto the back of this transformer like that, so we can view the voltage, the bias voltage of each 2-pill section. Now one thing I think I am going to do is unsolder these ceramic disc caps and replace them with silver dip mica. I mean, there's not a lot of voltage on there. I mean, I may just leave them. I mean, you ain't dealing with a lot of voltage whatsoever, but we'll see what the input reflect looks like, the input tune, all that good stuff. It's a real good amp, man. Real good amp. Really good amp. I like the bias section. I really like the bias section. I'm fascinated with bias circuits. I've always been fascinated by them. Whenever I see a new one, I will jot it down like this for future reference. So that is the bias circuit for a Skywalker 500. a voltage regulated bias circuit. All right, let's see what the voltage is for the first 2-pill section, 2 transistor section, which is right here. So all I got to do is just that keys, unkeys. All right, 0.68. Man, that's right on the money, son. That's what we're wanting right there, about 0.6768. All right, let's see what this next one is. Ooh, a little high, a little high. So what I'm going to do is I'm going to get down in there and I'm going to adjust that down just a little bit. Alrighty. Yeah, I use magnets to hold my tools. Alright, that was very nice and very easy. So we got that one adjusted. Right there at 0.668. It's right there on the money. Now I can tweak it and get it right there with it. These are the old school adjustments. They probably put it too high. Yeah, see? I should have just left it where it was. This ain't one of those fine multi-turn. I like the multi-turns. You can get them exactly where you want them. Alright, let's see. Alright, I'm leaving it. I'm leaving it. That's perfect. Alright, next we're going to inject some RF and make sure this thing's working and see what it's doing. Best thing for me to do, of course, is hook up my ham rig in here, but it's put up at the moment. But we just want to make sure that the amp is working fine. That's the main thing. Just make sure it's working fine. Be honest with you, I need to get my ICOM 718 and mount it out here, because now that I've got me a better radio, not a better radio, I've got me another radio that should really, I mean, to be technical with you, it should replace all of my radios up here. It really should. But I think what I'm going to do is double mount a couple of these Cobra 29s, double mount them on top of each other, and mount my ham rig up there for projects like this right here, where we want to see them, you know, work across the band on the dummy load and all that good stuff. So we'll just see what it's doing on the frequency. We'll be checking it now. All right, man. Here's your relay right here. I got it mounted right here on the side like this. All right, here's your feed through SWR. We're looking at it in a reflect form. Now, keep in mind, this is RMS here, so if we're looking at PEP, we're probably looking at about out of 18-20 watts going into the box. Let's see. That's a half a watt. We're probably looking at about maybe almost a watt coming back. That's just solely from these wires. The thicker the wire, the more of inductance you got, and just flowing through this relay. But what we can do is drop a small cap down in there and bring that down, and that will also bring your receive up just a little bit. I don't know if that's enough of a mismatch for you to notice, but we like doing things as perfect as we can out here at Gatekeeper Apps. I tell you what, man, this balancing network something else. Certainly gives me some ideas. But God, I still love the documentation that come with this amp, man. Whew. I want one of these. I really, really want one of these. I really, 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 really want one of these. All right. let's get that done first before we do anything else. Hold. Perfect. Just to show you the watts is still happening. I just ain't making noise. Perfect. So let me get that mic'd in. Alright, brother. I figured out the voltmeter is not working, which kind of sucks. Because I don't know where in the world. I think somewhere on the part list it says where to buy these from. So hopefully you can still get them. I don't know why it's not working. I flipped the box, you know, right side up to see if maybe that's why it's not working. But nah, these meters they're made. All these meters are made to be turned upside down. Ain't gonna hurt nothing. So it just isn't working. I mean, I'll look at it a little bit more and see. I mean, there ain't much you can do. It's an analog meter. For some reason it just is not working. But the box is working, man. With a box like this, everybody must understand that's watching this. It doesn't understand the ham boxes. They're used to narrow banded boxes. This is not a narrow banded amplifier. This amplifier is designed to work in a wide band of frequencies. Okay, you're probably wondering what the heck is up with all this right here. This is what I'm saying. This is a feedback circuit which is neutralizing this amplifier, which means it's dropping down the gain of this amplifier to equalize it amongst a wide frame of frequencies, pretty much 80 to 10 meters, or 3.8 megahertz, 3.7 megahertz, up to 28 megahertz or so. So what I'm basically looking for, normally a narrow banded amp you see me mainly messing with on my bench right here, with the amount of drive I'm about to be giving it, I'm normally going to be seeing about 450, 500 watts peak. But with this being what this is, we're only driving about 18, 20 watts PEP into it. We're going to get about 300 watts. As you'll see now, we're on 14.9 volts. This is PEP, 500 watt slug. We're reading the middle scale. Oh, I got to key the box first. Almost 300 watts. Here's your input reflect. Real good and low. Real good and low. And what's so crazy too, if you take a gander at this amplifier has no capacitive tuning on the input splitter. Take a look at that splitter. There's no capacitive tuning on it. It's so weird, man. It's just the way they've got it wrapped, man. It's amazing that they're able to get the reflect down that low without using any kind of capacitive tune. Now they got output, they've got capacitive shunts on the output. These two capacitors in series right here. And here's your combiner right here, combining both into 25 ohms, both 50 ohms to 25 ohms. And then this right here is up helping using a capacitive means to convert it back up to 50. But yeah, man, so I have to look to see what these boxes are designed to be driven with, but you're looking at a 500 watt box. Okay, so we're already up to right at 300, just a little bit under 300 just for that amount of drive. So I'm probably looking at about 50, 60 watts drive. I have to look at the papers again. I can't remember if this is designed to handle 100 watts or not from a radio, or if it's only designed, but I know you pretty much wanting to look at the amperage meters here, and they're both right there about equal. I'd have to flip it upside down to see exactly what they're reading, but we're gonna get everything put back together. This thing is done, And I got another radio I can hook it up. We'll give it a little bit more drive. Real cool amp. Real cool amp. All right, brother, we got it all put back together for you. Took the liberty of cleaning this up real good for you. I got a little mix here, man. It's very, 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 very light vinegar and water. I like using on aluminum. So this looked a lot worse, man. I know there's a lot better stuff to use with aluminum, but the inside the fins that got dirty, I cleaned that up best as I could. The only thing I was wanting to point out, I'm sure this was like this before you sent it, but if it wasn't, it was done during shipment, and I honestly ain't got nothing here to really straighten that up. About the only way I could think you could straighten that up is putting something over it, trying to tap it with a hammer. But the best thing, of course, you'd have to remove this whole back right here, but I'm sure it was done like that already, and it's on that side as well. So it appears that it was done during shipment. That's why I really like to padding these things up very, very, very well. But anyway, we got a little bit stronger of a radio hooked up now, so we're basically driving this with about 40 watts PEP. Still not max. I still got to look and see what max is, but still not max. And this is yielding us. Oh, I keep forgetting. Let me key it. Oh, yeah. Oh, yeah. All right. Oh, yeah. Oh, yeah. All right, bud. Go ahead and unkey it. And I made sure to turn this switch right here around and resolder it. Man, this is a good switch. So when I ship this time, I'm gonna put, or when I ship it this time, like I've already shipped it. When I ship this, I'm gonna make sure to put something on here so this will not get damaged. And I replaced all these screws right here up front with stainless for you. And man, this is a nice amp. Just to show you on the bottom, if somebody wanted to, they could always add them a little fan in there. I think that's an 80 millimeter, I believe. It's an 80 or a 92. And there's your porthole right there for the fan to blow through and blow out there, or vice versa. I would probably blow through. And these are pretty neat. These are from car tags. Yeah, car tags. First time I ever seen it done. Really neat. Glad to have been able to do this for you, man. It was a fun job, and the documentation that came with it was very informative. I'm gonna make a copy for myself before I send it back to you, man. I want one of these bad boys one day to add to my collection. Good little ham amp, wide banded ham amp, about a 500 watt, 4 to 500 watt amp. Skywalker 500 built from a kit. Old Gatekeeper right here around the northeast end of Georgia. 73, y'all. Bye bye.